There's a lot of information that goes into a router so it can make a final decision regarding the forwarding of a packet. And in this video, we're going to investigate some of those sources of information and some of the tables that a router would use to make those decisions. Let's jump in. Here are the opt-out questions for this video. So take a moment, pause your screen, and read these questions. If you're already comfortable with the content, hey, I'll see you in the next video. For everybody else, let's begin. I'd like you to take a look at these acronyms right here, one by one, and just in your own mind, think, do I know what that is, or have I seen that before? Because each of these plays an important part in the role of a router in making good forwarding decisions on a network. And what I'd like to do with you right now is go through each one of them and make sure we're both comfortable with what they are. The first one is RIB, which is a routing information base. And basically that's information on how to reach things. For example, if we have network 5.5.5 down there, or if we have network 1.1.1 over on R1, how do we let R2 know about that information, that routing information? Well, we use a control plane protocol, such as OSPF, or some other IGP, to advertise those networks so that R2 can learn about it. So OSPF is a control plane protocol that's feeding the routing information base. Now, once R2 has all that information, does that mean all those routes that he learned about go to the routing table? Hold on there. Not every route that we learn about over the control plane makes it to the winner circle, or as we sometimes call it, the routing table. Only the best routes, and a lot of factors go into that, such as administrative distance and cost and so forth. In OSPF, the administrative distance is 110. So if we have multiple routers who are advertising a network, the cost or metric would come into play for a single router making a routing decision. Now, once the router has all the information from the control plane protocol, such as OSPF, it can then go ahead and take those winning routes and it creates something called a forwarding information base. So here we have the RIB and here we have the FIB. And many years ago, Cisco came out with Cisco Express Forwarding so that the information in the forwarding information base, Ceph already has dialed in the layer 2 header that it needs to add if it's going to forward a packet out of an interface. So it doesn't have to think about it, oh, what's that layer 2 address? It's all ready to go. So Ceph by itself is amazing, Cisco Express Forwarding, and it's one of the reasons that basically IP forwarding versus MPLS forwarding, just raw forwarding of traffic, isn't necessarily that much faster with label switching compared to IPv4, because Ceph is so amazing. However, the reason that we absolutely need to understand MPLS and the infrastructure that we're dealing with right now in the course is because we're going to start taking advantage of MPLS and its labels to implement some really sweet MPLS applications like Layer 3 VPNs. So we've covered two of these tables, the RIB and then the FIB. And you can kind of think of the FIB like a replica, if you will, of the routing table that's all cached and ready to go. Next, let's take a look at LIB and LFIB. LIB stands for Label Information Base. And we're referring to MPLS labels. So on R2, how does it know what R1's local labels are for various networks? And how does R2 know what R3's local labels are for various networks and prefixes? And the answer is we're going to use some kind of control plane protocol for label distribution. And one of those is called LDP, which we've already addressed in this course. And I also want to point out that LDP is not the only way that we can distribute labels. We have some other tricky methods up our sleeves. But for now, it's the primary method that we're doing dynamic label distribution simply by enabling MPLS, and LDP comes up by default. So LDP is the mechanism that's feeding, if you will, the label information base. So R2 would learn the local labels that R1 has, and R2 would also learn the local labels that R3 has, and vice versa. Now, just because we learned a whole bunch of labels from both peers through LDP, it doesn't mean we're going to forward in both directions. For example, for network 5555 down on R5, it would identify, based on the IGP and the IPv4 routing, which of its neighbors owns the next hop from a routing perspective, and it's going to use that information to build the MPLS forwarding table. And that's what this guy is right here, the Label Forwarding Information Base, or LFIB. So as a review, routing protocols feed the RIB, and label distribution protocols feed the LIB. And once the router sorts out all that information, the best forwarding path will be put into the Label Forwarding Information Base, or LFIB, and the best IPv4 routing information will be put into the Forwarding Information Base. And then with Ceph, we are going to cache all of that information. For example, if you and I went to R2 and we said, what are you going to do to forward packets over to 5555? And we looked at the Ceph, the Cisco Express forwarding information for that, it would have everything it needed. If there were labels involved, it would have the label information. It would know the egress interface. It would know the next hop adjacency information as far as the layer 2 header it needed to put onto that packet. All that would be pre-built and ready to go. So that way, when a packet comes up, whether it's a labeled packet or a naked IP packet, the forwarding decisions have already been made, and R2 only has to execute. We're going to switch that packet based on labels or based on naked IPv4, depending on if there's any LSPs in place or not, and it simply makes the forwarding decision, and it can do so very, very quickly. So with all of these labels, it could be a little bit of a game of table tongue twister, because we have labels for tables, such as the lib and the LFIB, and we might have some label-less tables, like the rib and the fib. And due to Ceph, we are cached and ready to go regarding the information in the LFIB as well as the fib, so we can do any type of forwarding that we need to. One of the skills that you and I definitely want to have is the ability to predict the behavior of a given piece of equipment on our network. And to do that, let's play a game called If Then. Let's take R2 as an example. So we'll put R2 right there. And let's say we have some traffic coming into R2 that R2 is going to go ahead and forward. And if R2 is an MPLS router, which we also affectionately call an LSR, a label switching router, there's multiple choices as far as how it might forward a packet. And the big two variables that drive this whole equation are native IP versus labeled IP. And we're talking about IP version 4. So let's start off with an incoming IPv4 packet, naked, no MPLS label. As that comes into R2, and R2 looks at Ceph, if there is currently a label switch path for the destination IP address, R2 is going to inject or impose that label and send it. However, when R2 looks at that destination and in the Ceph there is no label information, it will simply forward it based on the routing table. So it'd be using FIB to forward it. So that'd be IPv4. And we'll put FIB right there, the forwarding information base. The next possibility is we have an inbound IPv4 packet that comes into R2. And looking at Ceph, there is a label associated with the destination network, at which time we're going to go ahead and impose or inject a label at layer 2.5, if you want to call it that, and then forward it to the next hop. So in that case, it would be MPLS, and we would be leveraging the LFIB, the label forwarding information base, that has the information on, hey, this is the next label, and here's your next peer. And Ceph is like Lord of the Rings, one ring to rule them all. Ceph is keeping track of all of that information. Now the next scenario is, what if we have an MPLS labeled packet that's coming into R2, and let's say that MPLS label is label 205, which is R2's local label for 5555. Well, way before this packet showed up at R2, R2 would have already created the label forwarding information base and said, oh, you know what, if I get a label 205, I'm going to go ahead and swap that label and push on the label for R3 and forward it as it goes down the label switching path. So presuming that LSP exists, R2 would go ahead and simply do forwarding via MPLS. And that also is going to be based on the LFIB. And we're talking about the actual forwarding or switching of that packet through R2. Now another possibility would be this. What if R2 gets a packet? It's an MPLS labeled packet, and it's labeled 215. If R2 doesn't have label 215, that's not his local label, he didn't source it, he didn't advertise it, he didn't tell anybody about it, but yet he's receiving it, what is he going to do? Well, in IPv4, what are you going to do with a packet if you don't know what to do with it? You're going to drop it. So in a scenario where we're receiving a labeled packet and we don't have any forwarding information for that label, we're going to go ahead and drop it. And the last possibility is we receive an MPLS labeled packet, and based on that label information, if R2 says, oh, the next hop in the path is not an LSP path, it could go ahead and remove or pop off the label and simply forward it as IPv4. And that forwarding would be based again on the FIB as far as the IPv4 destination. For example, let's say R1 has the 1.1.1.1/32, and he's advertising implicit null to R2. And let's say that the local label that R2 has for 1.1.1.1 is, let's say it's label 225. So as R3 forwards a packet to 1.1.1.1 over the LSP, R3 would go ahead and swap out the label that it received with label 225 as it sends it over to R2, and then R2 says, oh my goodness, R1's advertising the implicit null, the reserved number 3 label, which means I need to pop off that label and simply forward it as naked IPv4 to R1. He's being a good buddy by doing the penultimate hop popping of that transit label. Now, when I put each of these here on the right, this is the exit strategy, if you will, as far as when we're doing the actual forwarding. But it's important to realize that as that packet comes in, and the router takes a look at either naked IP packets or labeled packets, it's very likely that the label forwarding information base and the forwarding information base for IPv4 are going to be called upon as the router makes its decisions. And I mentioned this once before, but it bears bringing up again. If a router has a choice between forwarding a packet using naked native IPv4 or sending that packet over a label switch path, it will always choose the LSP if it exists. And if a packet comes in, for example, IPv4 comes in, and there is no LSP, it'll do the naked forwarding based on the forwarding information base. So the router might say to itself, when in doubt, use the MPLS LSP to send it out. And if there isn't MPLS or there isn't an LSP, IPv4 forwarding is there like any other traditional IPv4 router. I think it'll be fun if you and I do a few commands at the CLI to help verify some of these tables that we've identified in this discussion we've had. So to see the RIB, for example, and we're running OSPF in this topology, we could run the command show IP OSPF1, that's the process for the OSPF routing process I'm running, space RIB. So on R2, this is basically all the information that's in the OSPF RIB, but it doesn't mean every single one of these routes from OSPF made it or won and got in the routing table. See this greater than symbol that says installed in global RIB? I'd like you to pay attention to which ones didn't make it. For example, what's wrong with 2222? Well, 2222 is a loopback interface. Even though it's participating in OSPF, a directly connected network is going to have a better administrative distance than OSPF, which is 110. So even though it's in the RIB for OSPF, that route didn't make it as an OSPF route because the AD wasn't good enough. The same is true for 10.14, which is the directly connected network here that R2 has, and also for 1023, this directly connected network. So although OSPF is aware of those routes as OSPF routes, they're not good enough based on all the other considerations to make it inside the IP routing table. So this is one example of seeing the RIB from the routing perspective of a routing protocol, in this case OSPF. If we wanted to see the routing table, we could simply say show IP route, and that would show us the routing table on R2. Now if you're running iOS 12, you won't have these little L routes, and that's perfectly fine. But effectively, this is the winners list. So OSPF brought to the table virtually everything that wasn't directly connected. So the loopback was directly connected, and the 1014 and the 1023 networks, because they're directly connected, that's why those routes are showing up in the routing table, being represented as directly connected routes because of a lower administrative distance. So we've taken a look at the RIB and effectively the FIB, the forwarding information base, which is pretty much a mirror, if you will, of the routing table. Let's take a look at the label information base. And my question is, do you remember how to see the label advertisements on an LSR? Now, if you haven't quite mastered those commands yet, there is a solution for that, and that is repetition. Watch the videos again, and most importantly, practice, practice, practice. We're going to use the command show MPLS LDP bindings, and that is going to show us all of the label bindings on R2. So I'll hit the space bar to go ahead and go to the end. Let me scroll up so we can see the command together. So here's the command, show MPLS LDP bindings. And it is using liberal label retention, so it's remembering all the labels that are being advertised, even from peers who are not the optimal next hop. So in the case of our loopback network that's down here at R5, R2 has a local label of 205 for that, and LSR 1111, which is router 1, is advertising a 104, and R3 is advertising a label 305. So what we're looking at here is the LIB, the label information base. Now, how do we see the winners, the ones that we're actually going to use as part of the LSP? And if you're saying, ooh, Keith, I know it's show MPLS forwarding dash table, you would be absolutely right. That's the equivalent of the routing table for IPv4. The MPLS forwarding table is, again, that winner circle of what will actually be used as part of an LSP. So regarding this network, 5555, we are going to impose label 305 on that. So if we received a labeled packet that was 205, we would swap that with 305 and then forward it out gig 2/0 to R3. And all the information regarding the details for R3, for example, the layer 2 address, the label to put on, all that detail is already cached and ready to go. For example, on R2, we could do a show IPsef for specifically 5555 and the keyword detail, and that would show us some of that detail it's going to use regarding forwarding to that given destination. So in this case, Ceph is saying, okay, to get to 5555, here's the process. We have a local label of 205. Our next hop is R3. We're going to be sending it out gig 2/0, which is right there. And the label we're going to impose on it is label 305 because that's the label that R3 advertised to us via LDP, was R3's local label for 5555. All of this information is cached, ready to go. So when a packet shows up, we don't have to think a lot about it. We're simply going to execute and forward. So if R2 received a labeled packet of 205, it would make that switching decision based on MPLS and forward it. If R2 received a naked IPv4 packet, meaning there was no MPLS information, if it was destined to 5555, based on Ceph, it would impose an MPLS label on it and forward it over to R3, down the LSP, towards R5. Now your action item for this video is simple. I want you to practice what you've seen. So we're using the same topology that we built back in the implementing MPLS video. And here I want you to focus on taking a look at the label information base as well as the MPLS forwarding table using the show commands that we've done in this video. And the great thing is, the more you practice, the more comfortable with those commands you'll be, and then you can take those skills into a production network. And if you're troubleshooting MPLS, you'll be that much faster in identifying and solving that problem. The other thing I'd love for you to do is go back to the opt-out questions at the beginning of this video and make sure that you are now comfortable with the answers to those questions now that we've spent this time together. I have had a great time and I'm so glad you joined me for the video. I hope this has been informative for you, and I'd like to thank you for viewing.